let's talk statistics. Specifically, let's talk about some statistics that will come up if you're doing any sort of analysis that involves numbers or other quantifiable things as part of your dissertation or doctoral study or project. These will also come up in many sciences and social sciences master's degrees, so if you're not a doctoral student, this may also be of interest to you still. And with that, let's just start with what we're talking about. Statistics are a tool in the data analysis arsenal. When we talk data analysis, we mean that we're trying to achieve one of the four basic scientific goals. We're trying to describe something, we're trying to predict what will happen, trying to explain what is happening, and to control for other variables to understand what is or isn't going on, what is causative or likely causative or not. And so when we talk about data analysis, statistical data analysis is a subset using information that we can put into some way of recording that is, well, not necessarily numeric, something that we can tabulate, that we can count up, that we can make sense in terms of quantities and look at relations and patterns. Now, statistical description, something that almost always comes up when you're doing qualitative or quantitative research, is describing what you got through descriptive statistics. And it can include things like listing the different parameters, the central tendency, which is describable in three classic measures. There's mode, median, and mean. And these have different ways of writing them. So when you say average, you should always specify what kind of average. Usually you mean the arithmetic mean, the capital M in italics in APA style. The median will be the value in your data set that is closest to the middle. The mode will be the value that comes up the most frequently. And mode can be interesting to look at for some things, but usually not so much in the kind of analysis that we'd be doing in social sciences or hard science research. So there is no abbreviation for that in APA style. You can still put it in a table, and you would write mode for the table label, but it's not something that comes up a lot. So it's usually reported incidentally rather than as a key or important detail. Now, another part of descriptive statistics is looking at the variability, and this can have a number of different things like the range, what's the difference, what's the gap between the largest and the smallest values in the data set, the variance, and in particular, this comes up a great deal, standard deviation. And the easiest way to explain a standard deviation I have found is to say that in a quote-unquote normally distributed data set, something that follows a bell curve shape, you'll have your median, okay, that's the value in the middle, your average, and then a large portion of the data will fall within one standard deviation, greater or lesser. And by a large portion, I mean 68% will be either median plus one standard deviation down to median minus one standard deviation. And that is the definition of these values. We have the median, and we count up or down, and then we have about 68% of the data fitting into that. Now, with a normal distribution, we'll have 95% of the data being within two standard deviations. So if you have, say, grades for a test, you usually, if it has let me back up. If you have grades that follow a normal distribution, normal in the mathematical sense, 95% of the grades will be within two standard deviations of that median. So you can have things that are really at the high end. Let's say your median is rather unfortunate grade of 50% of the test values, the points that you can get, and 95% of the students are going to get between 30% and 70% in our example here. And yeah, there'll be a couple who get 70 to 80, but that's a very small percent. That's less than 2.5%, and a couple who will get really low. Now, not all data follows a standard distribution or a normal distribution, and so when you're plotting your data, you want to see, does this fall within or without? And that will give you an idea of the patterns. And if you have a lot of things that don't really resemble this, then you might look at, okay, well, is this accurately predicting what we're looking at here? Now, there are formulas for calculating the standard deviation and the variance. The variance is the squared standard deviation. But you don't need to worry about those details so much in SPSS, so long as you know what the values are that you are plugging into that. Now, not all distributions follow that normal thing. Often you'll find that you graph things and it's skewed. And you might have some outliers that you ignore because they're so outside the rest of the set. But you can have it's negatively skewed or positively skewed, and you might also use it left skewed or right skewed for where what it would be the bell curve is tilted in either direction. So, is it symmetrical? Does it follow that normal distribution, or is it skewed? Now, you also have drive scores where you're looking at, okay, how are we dividing this up? And that's where you get things like their percentile ranks. And in some things, you'll be looking at, okay, well, do we have a z-score? And the z-score is one of those measures of how close we are to the mean. And again, don't worry about the formulas too much, so long as you understand the values that you're plugging in. And it's just a way to arrive at a set of numbers that will tell you how close we are to this. I think it is always a good idea to plot your data and see what it looks like. And this will tell you a lot about whether you have extreme cases that are not necessarily representative. And when you're looking at doing correlations, you want to look at the shape and the distribution. And generally speaking, if you were graphing the correlations, we're going to be seeing something that is grouped more into a line for a strong correlation, and the slope, whether that's up or down, will tell us whether it's positive or negative. Now, if we don't have a clear line, if we have more of a cloud, then that's going to be a weaker distribution. And if it just seems randomly scattered, then we're going to have no correlation or no meaningful correlation. So that's one way to understand it. But you can also codify the correlations in terms of numbers. So 0 is no relationship. 1 would be a perfect correlation, positive, so this goes up, this other thing goes up. -1 would be negative, so perfect negative correlations. One thing goes up, the other goes down. And that's very helpful for understanding if things seem to be related in terms of changing at the same time and investigating causality, where something will cause another thing to change. As an example, if you're driving, your car usually gets different mileage at different speeds. Because the engine is tuned for specific speeds, it's carrying a certain amount, but it functions more efficiently. So, if you have a van, generally it's not getting the best mileage if you're driving over 65 miles per hour. Usually its sweet spot is somewhere lower. But race cars tend to have less efficiency at those lower speeds because the engines are tuned so high. Another thing that is helpful for understanding is that you will have a calculation for sampling error to look at different areas where you can diagnose problems with this, and sampling error is one of those things where it is driven in part by how large your sample size is and if there are any biases in the data. So if you have a large sampling error, then that is something that may affect how you interpret the results. Sampling distribution, this is also one of those things where you're looking at, you have a set of values, and you're wondering, okay, well, is this a tight distribution or a loose distribution? And what does that tell you about what you've gotten and what you might be able to derive from that? So you might see that, oh yes, there is an overall positive, but there's so little difference in the range of values that it's not really statistically significant. Or you might have so much range that it's really hard to derive conclusions from that. You let's say you're talking movie screening and you poll people on that, and then there's some people who are, this is good. And then there are a couple of people like, I absolutely hate it. And you might see that there's such a degree of difference there that you end up excluding some data, or you look at it and say, well, we have such a distribution here that it's hard for us to derive anything meaningful. And so you might go back and look at this and look at your degree of correlation and say, well, okay, we got these results, but we have a lot of outliers. And so that's a caveat when you're interpreting the results. Sampling distributions, this is something where the terminology is very descriptive, and we want to make sure that you understand that parametric is about the shape, normality is about the shape, the distribution, and homogeneity of variance. Are you seeing a lot of variance in one type, or are there all sorts of variance? And this is particularly important when you're trying to look at multiple potential variables for correlation. All right, when we're talking about confidence intervals, this is something that students often have a lot of questions about. And if you read in some journals, you'll find that they're using different confidence intervals. Usually 95% is recommended. So that is basically saying, okay, well, how confident are that these numbers are reflecting a trend? So you have, if you're checking at the 95% confidence interval, you're saying, yeah, we want to be pretty reasonably certain that this is what we're seeing. Another one, hypothesis versus null hypothesis. So the null hypothesis, briefly, is if you make a hypothesis that something is the case, the null hypothesis is simply, okay, well, that's not the case. That's not true. And so you could break it down in terms of logic, but usually you're looking at it and saying, okay, well, if our hypothesis is this, any result that's not that is going to be disproving that. So, for example, if we're looking at a bunch of statistics about how people watch television, and we see, all right, the average American watches 25 hours of television per week. You could hypothesize that the average for another group, and in this case, in this notation, X with the bar over it is indicating our mean here, the arithmetic average. We say, okay, well, our hypothesis H0 is that the mean will be 25 hours per week. And if we're disproving that, well, our alternative hypothesis, it's not 25. Now, it could be higher, it could be lower, but it's basically saying, okay, if it's not 25, then our hypothesis is wrong. Now, you can go ahead and do statistical tests, so it's not just you're looking at and trying to reason out in your head. This is one of the reasons why you'd be using a program like SPSS. Now, this is going to spit out a couple different ways of writing things. So this little symbol here, that is our standard deviation. And in APA style, if you format your output, and there's a option in SPSS to select APA style, then that will become SD in all caps and italics, rather than that symbol there, which is a Greek letter. It's also helpful to look at the p-values, because if you set your p-values too high, you're not going to find that you have the right threshold. And so if you have, say, a p-value of 0.05, a lot of people will say, well, you're not being strict enough in your criteria. And so they'll suggest that you use a more strict and more small p-value. Errors, there are a variety of different errors you can run into, but they all have to do with interpreting your results. Do you have a null hypothesis that is true, is false? Are you rejecting a hypothesis or not? You might also look at, hold on, let me fix this slide. Now, something else that you might be finding when you're looking at other people's analysis is looking at how the data is related to multiple factors. Now, if you're doing educational research and if you're doing nursing research, this is probably not going to come up. But there are ways that you can look at correlations by region. And that's not just about physical regions. I've had students who were doing work on emergency room layouts, and so they ended up doing spatial analyses where they're looking at different points and what correlated with the different places that people were setting up or where equipment was located, which is really cool. But it does come up when you are looking at saying, do these conditions apply to another area? And in some cases, that's about stress. It can be about access to equipment and times, or it could be about how this phenomenon in one area does or doesn't apply to another. Think about areas that are in close physical proximity but have geographic barriers or transit barriers that prevent them from functioning or behaving the same way as another spot. So while it might be very easy to say, okay, we're looking at things within 50 miles of this location, you might want to go and tag things by access. Lived in the Twin Cities for many years, and there's a neighborhood called Rondo that had a highway built through it. And so it chopped it into a north section and a south section. And they were physically close, but there's a highway with no bridges over it and no tunnels under it for a long time. And so that did not mean that North and South Rondo were developing in parallel anymore, and they weren't interacting as much. So that is the example where you might go through and discover that to spot the meaningful, interesting trends, you might need to be adding geographic tags in your data so you can disaggregate what is in one place versus another. Because even though they may be in the same zip code or some other derivation place, there may be another factor that you need to take into account so that you have a high confidence interval and you can use a low p-value, etc. So that's it for now. Some resources you might be interested in. There are many excellent books about statistics and many excellent videos on YouTube. You also have access as an ACU student to tutor.com that does have statistics tutors on their staff, and you can access them up to 10 hours per semester, I believe is the current default. But if you have questions about statistical terminology in your dissertation or course paper, you can send us an email at onlinewritingcenter@acu.edu if it's a quick question. If it's something more lengthy, do recommend that you schedule an appointment. And with that, bid you good night.